Okay, 9H kids. I'm going to be doing two proofs in this video. The first one is the triangle sum theorem. Triangle sum theorem. So, as you know, the sum of the measures of the interior angles of any triangle is 180, right? We already know that. We're going to be proving it. So given triangle ABC, prove the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. And you could draw any triangle ABC, it doesn't really matter. So we're going to start off by drawing in an auxiliary line. The auxiliary line we're going to draw, now this is going to have to be put in the proof. I don't know if this has been touched upon, auxiliary lines. I don't think that you are aware of what they are, but I will show you what an auxiliary line is. It's literally just a line that you draw in the picture, so I'm going to draw in this auxiliary line. I'm going to put it in the proof. I'm going to put a letter here so that I can name my line. Okay, so draw auxiliary line CD parallel to AB. And the reason you're allowed to do this is because through any point not on a line, there exists exactly one parallel line. Through any point not on a line, there exists, feel free to use the backwards E, that stands for there exists, exactly one line parallel to the given line. So let's put in two angles to make our lives easier, 1 and 2. Now, there's something called alternate interior angles. So if I make the letter Z here, these are alternate interior angles, which will be congruent in the presence of parallel lines. And then I'm going to make a backwards Z, and these will be congruent as well. So, statement 2, angle 1 is congruent to angle A, and angle 2 is congruent to angle B, and that's because when we have parallel lines, the alternate interior angles must be congruent. Then the next thing we're going to do is we're going to talk about linear pairs, right? So what we have here in line 3 is angle 1, and then this other angle ACD must add to 180. Well, if you look at angle 1, let me just highlight this in yellow. If you look at angle 1, and then you look at angle ACD, I know it's a lot of colors here. We know that those angles must add to 180 because linear pairs are supplementary. So we're going to put angle 1 plus, let me just put measure. The measure of angle ACD equals 180. Linear pairs are supplementary. Okay, well, the next thing that we can say is that angle ACD, if you think about it, right? Angle ACD is equal to the measure of angle 2 plus the measure of angle ACB. So the measure of angle ACD, which is that red angle up there, is equal to the measure of angle 2 plus the measure of angle ACB. And the reason for that is that you have two angles that add up to an angle. So we're just going to call that angle addition. Postulate. Then, what we can say now is we already know that we have this measure of ACD. Well, this angle, ACD, plus angle 1, we said that that equaled 180. But then we know that angle ACD is equal to the measure of angle 2 and the measure of angle ACB. So what we can do is we can go back to line 3 and we can just replace ACD with this sum. Sorry, this is line 5. I think I wrote a 4. So we have the measure of angle 1 plus the measure of angle 2 plus the measure of angle ACB must equal 180. That's just substitution, because we're replacing equals with equals. Then keep in mind, we had said earlier that angle 1 is equal to angle A. So we can replace angle 1 with angle A. And likewise, we said angle 2 is congruent to angle B. So somehow I left out my 2 here. Sorry about that. We have the measure of angle B here. And then we have the measure of angle ACB equals 180. And that is literally proving that the sum of the three angles in any triangle must add up to 180. And that's substitution property. Quod est demonstratum, that which you set out to prove, you have thus proven. Okay, so let's take a look at another proof that may be of interest to you in this unit. Okay, and that is going to be to prove that the exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So we're going to prove that the exterior angle of a triangle equals the sum of the two non-adjacent, some people call them remote, interior angles. All right, so I'm going to be given a triangle. And in this triangle, we will draw in an exterior angle. So we want to prove that this exterior angle, which I named angle 1 to make our lives easier, we want to prove that that equals the sum of angle A and angle B. So we start off, we have our statements and our reasons. Now we're given the triangle. So number 1, triangle ABC is given. Line 2, we know that the 3 angles of the triangle, we already proved this, the measure of angle A plus the measure of angle B plus the measure of angle 2, we know that that equals 180. That's the triangle sum theorem, which we just proved. Line 3, we have angle 1 and angle 2 are supplementary, right? So the measure of angle 1 plus the measure of angle 2 is 180. Linear pairs are supplementary. Now what we can do is we can substitute. So we have this equal to 180 and this equal to 180. So therefore we can just set those equal to one another, because we're going to replace this 180 with this bottom part here. So we have the measure of angle A plus the measure of angle B plus the measure of angle 2 equals the measure of angle 1 plus the measure of angle 2. That's just substitution again. And then we're allowed to add or subtract the same numbers from both sides. So we're going to subtract angle 2 from both sides of the problem. The measure of angle A plus the measure of angle B equals the measure of angle 1. And that's just the subtraction property of equality. You actually learned that in algebra. All right, you learned that you can add or subtract the same values from both sides, because measure means we're dealing with numbers. So we're dealing with equations here. And that's it. We have proven what we set out to prove, that this angle, this exterior angle, equals the sum of these two non-adjacent interior angles. And it comes really in handy, as I showed you in class, right? So quod est demonstratum. All right, guys, I didn't have the class time to commit to this. That's why I made a video. All right, thank you so much.